Hey everybody, this is Larry. This is day 9 of the December Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let me reset this because I don't know when I saw it. I don't know, is this like, I guess it was a year ago. Maybe it was on Vine 32 or Vine whatever. Anyway, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. 1026. Maximum differences between Node and Ancestor. I don't know why I have all these on thing. They're running on loop. I mean, they have like 2,800 problems, and I don't know why I'm getting so many loops that I have it in memory. But anyway, let's take a look. What are we doing? Maximum difference between node and ancestor. Okay, so given a root of a tree, find the value, maximum value v, which there exists a different node A and B such that b is equal to A dot value, and A is an ancestor of B. Okay, so what are we saying here? So basically, given this root, 8 and 1 is, does it have to be leaves? No, it just has to be an ancestor. Okay. And it's the absolute difference. Okay. Okay. I think I get it. Okay. I think I get it though. I don't know. Oh, I'm not quite sure what I want to do here. So we have two different nodes. I mean, obviously, if they're the same node, I know it's 0 anyway. So I mean, I think the thing that yeah, just double checking the n is 5,000, so you can't do anything n square. And in the worst case, it is going to be n squared if you're not very careful, in the sense that if you have a linked list tree, if you want to call it that, then and you do some like comparison there, it's always going to be n squared. So we have to avoid that. Okay. So how do we do it? So for each node, we want to calculate everything, right? I guess there are only a couple of things, right? I mean, and this is, I think the thing that's throwing me off a little bit, to be honest, is the absolute value, which is the difference, right? Because if we're thinking about, because then now you can break it into two cases, right? Because it is either, what are we maximizing? So basically, because let's I'm just trying to think about how to explain it, but let's consider a variant, right, where instead of the absolute value you want to do a dot value minus b dot value. This is what you're optimizing. You're trying to max this thing, and to keep in mind that we are not optimizing the absolute value. We're optimizing just this value over the tree, given the constraint about ancestor and child and stuff. In this case, in a greedy kind of way, we basically, for every node, A is the ancestor. Yeah, okay. So A is the ancestor, and then that means that here, if we want to maximize this formula, then we want this to be the biggest that it can be. But you can technically you could just look at every part, and then here you want it to be the smallest that it can be, right? So yeah, so that's basically the idea, right? And in that sense, here we'll consider every node, and then here, then it'd be another way to phrase it. Then is that for every node, calculate the minimum, not children or descendant, yeah, the descendant, I don't know how to spell, with the minimal value, right? So then we can do that and then do the calculate and then max over the entire thing for every node. So that's one way of doing it. And then of course, if we think about absolute value, then it's just two things, right? It's either this minus or another way of writing this maybe is just negative a dot value plus b dot value as well. So we maximize one of those two, right? And then for this one, it's the same idea, right? Here, we want this to be the max that we can be, and this is just the value that we calculate, right? So that means that for every node, calculate the descendant with, I spelled it again, the maximal value. So that's basically one way to kind of break it down, and I think that's the way that I'm going to attack it. I think in general, in the past, I have definitely struggled with absolute value and how to kind of, figure that out. I wouldn't say that this always works, but this is a way. This is a way of attacking the problem that break it down to easier components, right? So okay. So then now, and this is a binary tree, right? Yep. Yeah. So then now we can just go. Okay. Well, we can return both the max and the min, and then just kind of calculate these, right? Yeah. Right. So basically, let's just say we have a traversal, and this is the theme of this this thing anyway. Maybe return. We want to return the min and then the max. So then let's just say infinity and make it infinity as no values, right? And then we want to traverse node.left to get the left nodes, right to get the right nodes, and then now we process it, right? So yeah, I don't know why I'm struggling a little bit today to think clearly. Maybe I just took a nap or something. That's why. I don't know. But yeah, but basically now, I mean, obviously, we want to return. Let's just say min of left of 0, right sub 0. We're trying to get the smallest value, and then max of left sub 1, right sub 1, and then node sub value, right? So these are the min and the max, and that's what we're returning. One more thing that we want to do is, of course, calculate these things, and then we can maybe just have, I don't know, I think you can also pass it up, but you can also pass it up in a recursive way, but I'm just going to make it a little, I don't know if this is clear, but I'm just going to do it here. Maybe even negative. I think that was fine. Maybe. What the only one node or 2 node? I guess only 2 node, then it cannot be 0. Okay, fine. Then non-local best, and then like we said, we can do best is equal to max of best. A dot value. Oh, A is no dot value minus the B dot value would be left. Okay, so I'm just reading here the minimum value, so left of 0, and also or right sub 0, right? And then we can also try the other side as well. This is technically negative no dot value plus left sub 1, node forgot the negative again, plus right sub 1, and then that's pretty much it, right? And again, you could do it in a way that returns it, but okay, so that looks good. Let's give it a submit. Didn't really look at the time and stuff like this because this is linear time, linear space. It's the theme of the entire week around trees, so I mean, the space is going to be the height of the tree, and everything is just linear time, right? Yeah, that's pretty much all I have for this one. Let me know what you think. I am going to do an extra problem today just to kind of, I don't know, because I have a little bit of mind fog and I kind of want to warm it up for the advent of code. So I'm going to do an extra problem today, so stay tuned for that. Hit the subscribe button if you haven't already. Hit the little bell if you want to get notified. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.